I wanted to introduce and start the session with this here. Any thoughts on what that could be? Any guesses here in the early morning? Don't be shy. No guesses? I'll give you a first hint. Any guesses, Vlad?
Number of businesses using Neo4j. I mean, no one exactly.
Could be. No, that would be exponential. So I'll give you a second hint here. It involves biological processes. I give you another hint. That's not a graph. This is what we call a chart. So, any other guesses? Last hint. You don't need any analytics, agents, AI whatsoever. You don't need it because it's the development of the beer price of the Oktoberfest. So if you're in that business, you can make sure that the price goes up and your revenue goes up. So you don't have to do any crazy intelligence. So if you're in that business, you can grab a coffee and relax. For all the others that have the real challenges, complex data, you stay in the room, you stay with us, and I hope you will learn a lot and you'll have fun today. So just as a fun fact, because I worked as a working student, I worked for a PR agency for the Oktoberfest back in the days, like 20 years ago. It was 300 liters every second for 2 years. Some people might call us alcoholics. I would say yes. So yeah. Jokes aside, let's kick things off. Today we are here to talk about graphs, obviously, graph databases. We're talking about agents. I think a lot of our customers of the presentations will have a combination of agents or analytics on top of a graph database. What analysts say and what we see, and probably you have read that in the news already, the AI fatigue is real, right? The models are really good, they are powerful. What they are lacking is the foundation underneath, which is the data, right? And not only the data, and this is what Gartner says, the data is fragmented, so it's not connected. And it's also not connected to the context, which is why agents have a hard time, or they hallucinate, or the accuracy is not high enough in order to actually use that in production in our business. So you might have seen numbers. This is just one number from one of their reports. Some say 80% will fail. Whatever it is a big number of projects that will fail in the next couple of years. And the reason is because the data is not AI ready, or not contextualized, and not ready so that the agents can leverage the full power of that. And they said in late 2025, underneath your AI, underneath your agent, your multi-agent system, what you need is a thing called a knowledge graph. This is what we're here for, right? Because the knowledge graph gives you not only the data itself, it also gives you the semantic relations and the connectivity of the data itself, which makes AI being grounded, reducing the hallucination effect, you will see that in a second, or you increase the accuracy. And last but not least for me, one of the most important points here, why we are doing graphs and just graphs, obviously in Neo4j, is because we can keep the explainability and making AI trustworthy. And I always say, like, if you want to approve a drug at the FDA and you say, well, the AI said so, I don't know, probability 0.9, whatever, right? They will ask you, so what's the data behind it? Can you prove that? Can you explain that? And this is what you will see a little bit later. Cool. You probably heard in the last couple of 2 years, maybe everybody talked about RAG, retrieval augmented generation, which is vector-based only. And you will see this in this very next example. We have vectors. We can call these vectors very efficiently, which represent the semantic meaning of the sentence. We can query it, but it's hallucinating, and the accuracy is not enough, which is why we have GraphRAG, so connected context to that. And just by giving you this example here on the left side, this would be representing a vector database, a RAG approach. And what you see here are these vectors, or they're calling it embedding vectors. That is a representation, a low-dimensional representation of your actual data. So anyone familiar with embeddings? I think yes. Okay, cool. So we have 3 different vectors. They're representing a data record called AD, AD, AD. You see the distances here. So these are our results from the example. I know it's very high level, but LLMs start to hallucinate on that because we don't have the context here. And when we compare that to the right side, a graph plus vector, so giving the context, we can distinguish between the different vectors by enriching the actual data records, AD, with the context. Any guesses? I made that example a lot of times. Any guesses what AD could stand for? Any guesses? Brigitte? AD. Anyone else? Yes? Alzheimer's is very good. So your context might be clinical space, right? I'm a doctor, I'm a clinician, I'm a biomedical researcher. Yes, so your context actually explains what AD means, right? Any other guesses? Adjustment, I don't have that on the slide, but good one. Björn.
Active Directory?
Active Directory, we'll come to that in the third one. So second one is my past. I used to be protein crystallographer, alcohol dehydrogenase, an enzyme degrading alcohol, right? Completely different context, but still referring to AD as a record in my database. And then last but not least, Björn, have you seen that before?
No, it's
Okay, Active Directory. So Björn has Microsoft in mind. Are you a Microsoft job at KWS? No.
But everybody, all corporate organizations are Microsoft by heart, right? So
Yeah, and imagine if you are sending the 3 records on the left side to your LLM, you know, like answering your question, and it's hallucinating about Active Directory, right? While you are the Alzheimer's disease person, right? So you see, this is the difference that we have with graph databases, querying the context. And this is a very high-level example. I just give you another one here. If we think about recruiting, I don't know, patients to our clinical study in diabetes, we could say, well, let's take the transcriptomics, proteomics, whatever omics experiments, represent that as an embedding vector, and then query it. So I did the same example. We have the RNA fingerprints, and then we are querying the context. So for experiment number 1, we have a connected Mondo ID or whatever DO ID, where the context is, again, metabolic diseases. It's a disease probably connected to a patient, so diabetes. Okay, that's a good one. You see there the unconnected ones. Is that working here? So here we go. So you see here the some of the genes here. I will come to that in a second. So we can query all sorts of context here. Second one is a very similar RNA profile in transcriptomics, but has no link to any disease, right? That might be not really a good candidate for recruiting to the study. And then another one, just a random example here, could be Parkinson's disease, right? So you see, depending on the context, you can take decisions that you cannot do with vector only. Okay, and just like to stress that point a little bit more, what does context mean? Context can mean very many different things. Like it can be connected, I don't know, your multi-omics experiment is connected to some sort of genes here. We might even have an expression value here on the relationship stored. And then these genes are obviously connected to molecular pathways. The pathways are connected to phenotypes or disease phenotypes. And then for the diseases, we have, I don't know, a clinical study, NCT there with the identifier. So you see the points like, depending on the number of hops that we do, and this is what we call hops, going from one node to the other, we can query the context very, very efficiently and very, very fast. Cool. So that brings me a little bit to the challenge how to build this knowledge graphs. And this is actually the step 0 for me. Companies like you have typically 3 problems. The data that we deal with, especially in R&D, but also in supply chain, for example, is extremely heterogeneous, right? There is not the one omics experiment. There is not the one identifier for everything, right? We have extremely heterogeneous data. At the same time, data is highly connected by definition, right? If you open up your biology book, a gene, arrow, protein, right? A gene is coding a protein. Protein, arrow, function, right? A protein has a function. So we as humans, we think in graphs. But we didn't store it in this way. And that's why we're putting it back into a graph database so that it is connected and that we can query the context very efficiently. And the last one is, I think you would all agree, we have a lot of unstructured data in our business. Publications, legal documents, reports, whatever, even images or other experience. So we have a lot of unstructured data that we can now leverage using LLMs that they can help for the heavy lifting. And that brings me a little bit to another report by the analyst, also Gartner here, who say, well, once we have that knowledge graph, we can take the next level, which is called context graph, where we can not only query the data and the context of the data, but we can also persist memory of the agents and memory of the different tools of the agent and keep that in the same database, and then even connect the decision steps to the actual data in order to make things explainable or just easy queryable if we think about token cost. So persistent memory, this is a topic that we deal heavily nowadays. I think Jean-Marc is taking that a little bit in the afternoon, some sentences. Again, for me, very important point is that things are traceable. We can always go back to nodes and relationships and make it explainable so that we can be sure where the data comes from or what kind of decision has been made. And last but not least, this is the last report I just bring up. The context graph as such is the next step of evolution that will probably be in 2027, 2020 here, will be the next big thing underneath your AI. All right, cool. As I said, we are a graph database vendor, so we are on the left side. What people are doing is building a knowledge graph with the semantic meanings and with the connectivity of what you have in your database. And then next kind of evolution is next to the instance data, you have your decision tracing, you have your agent memory, short-term, mid-term, long-term memory that you keep in the same database. All right. Neo4j is a graph intelligence platform. What does that mean? So on the left side, you saw the database layer. We are a database company that can be on-premise, so self-managed. They can be fully managed in any of your clouds, even in your own cloud. What we ship on top of the database is so-called graph algorithms. Have you heard about graph algorithms before? Probably most of you. Björn, you know it. You will show it. One of the most famous graph algorithms is PageRank, used by Google to rank up and down the hits in your Google search. It's a graph algorithm, so importance factors that are derived from the graph structure. So we are shipping out of the box, I think it's now 78 algorithms that are working at scale, where you can use your knowledge graph and use the relationship explicitly in order to make assumptions, create new insights, and so on and so forth. We are also providing a lot of tooling for connecting your knowledge graph to the LLMs. So this is what we are heavily investing now with 100 million in the next couple of years. One example of that is, and that's why I called this out here, is the document intelligence. Coming from documents, and you can imagine that there are a lot of people that are non-experts, not technology-driven. They don't care about Python or a graph database even. They just want to know what's in my unstructured data. I want to drag and drop it and then do some intelligence on that. I want to chat with my data. So what we build currently, and Jean-Marc, you are showing that a little bit, right, in the afternoon, spoiler alert, how to easily work with your unstructured data. Brings me a little bit to the use cases that we see with the pharma and life science customers. What I depicted here is the drug life cycle, starting from R&D from the left, and then we are moving over preclinical to clinical, manufacturing, supply chain, some commercial use cases, even compliance, governance, legal tech. And what you see here is that we are covering use cases across the value chain, and we're working with all the big companies. So it is really a powerful tool, a powerful database that many companies are using. Using the drug lifecycle, this is how we structure a little bit the day. As I said in the beginning, we're starting with R&D use cases, clinical and legal before lunch, and then we have a lunch break, and then we have some two cool use cases in supply chain and manufacturing, and then, as I said, as a little technical deep dive and new product updates. Cool. So As I said, we're starting with the R&D part. Most of the R&D is based on a knowledge graph, and typically what everybody does is connecting the usual suspects here. Genes and proteins that are connected to compounds, regulating different things, I don't know, even a pathway. Most of the customers are connecting that to clinical trials or to approval information. We will hear from Sandoz, you're connecting that to patent data or IP relevant information, to do competitive analysis. And we have also Kaijin here in the room. This is what you can also buy as a product. So you can do that on your own. I did it on my own when I used to be a customer. You can also buy such a data set and load it in 1 or 2 hours, and then you're good to go. So that's the basis, and this is what we have. Different approaches here. We're starting with Vlad from Bayer. Bayer used the last 2.5 years to build a huge knowledge graph, and Vlad is presenting a little bit the machine learning on top of that. Björn is also covering that, right? A little bit of visualization and graph algorithms, and then we have Brent virtually dialed in from BSF Crop. They have a knowledge graph on crops like Syngenta, on wheats and rice plants, in order to find information to make plants resistant. Cool. As I said, one of the new features is called document intelligence. In a nutshell, and it's really something that is no code or low code even, what we can use in our Aura platform, our cloud offering here. You can upload your data by drag and dropping your PDFs, your PowerPoints, your Markdown files, whatever it is, or you can point it to a SharePoint or a Google Drive, and then you can define the data model here, what the LLM should extract out of your unstructured data. So you can use your local LLM, you can use OpenAI, whatever you have. You can use an ontology even to drive that data model to say, okay, I'm only interested in this and that and only in molecules, or my definition of a molecule is a bispecific antibody and not a small molecule. So you can direct the LLM to extract the information from the unstructured documents. And you're then loading that into a structure called a knowledge graph, and then you can do all sorts of stuff like querying, visualization, stuff like that. I plotted here the documents. This is what we see with the customers, just like some examples where documents and unstructured data can come from. And as I said, we are sharing the slides, so I don't want to go into detail. Just to pick a few of them, because we had this last year here for competitive intelligence, and also what Sandoz is presenting later here. Legal documents are super interesting. Annual reports from maybe your competitor, right? Or clinical trial information that is publicly available could be leveraged now and being queryable for the customers. As I said last year, and this was not recorded, Novo Nordisk presented the use case of competitive intelligence where they ingested 150 million documents. So it's a huge beast of a knowledge graph that serves various different applications, being a chatbot, being a key opinion leader analysis, identification of healthcare professionals, obviously knowing more about your competitors, knowing about trends, and maybe even trends that are just upcoming. There is a researcher, I don't know, Conrad, sitting somewhere in Berlin doing research on a completely unrelated gene. Oh, well, there's a connection now. So why is that? So this is what they're doing with the knowledge graph. As I said, we have Sandoz here in the room. Piyush will present that, so I'm super looking forward for that. They are using it the other way around, right? Sandoz is a generics company. They try to fight against patent evergreening or kind of extension of indications or drug repurposing. I'm super excited to see the latest and greatest results of that. Don't want to spoil too much here. That brings me a little bit to the clinical part also. A super interesting use case from Inselspital. So Karen and Olga will present a knowledge graph that is connecting heterogeneous data in all sorts of different languages and IDs that have to be mapped in order to link medical documents. So we will hear that just before the lunch break. And then for the people that are streaming live here, we have two presentations while we are having lunch here. So Christian and Isaac will present also two medical use cases. Christian got awarded some weeks ago on his project in Switzerland. So yeah, also excited to hear about that. And then, as I said, next to all the R&D use cases, medical and legal, one of the most prominent graph examples is supply chain and manufacturing. And why is that? Because what big companies are doing is they are having spreadsheets, databases, scattered data, not harmonized data, and it's very hard to react on a contamination, right? Or there is a deviation of this and that. So we want to track and trace, and we want to report it, and we want to make that explainable. So just to give you a small hint on how things are connected here, and I think you can easily understand what I'm talking about. Let's say we have here some batches in our database, right? And some of them are having either a deviation, or we even have a complaint here, right? So this is connected to a batch or to, I don't know, 5 batches. And so we want to investigate this with a graph database. And because everything is connected for us, it's relatively easy to say, okay, this batch is obviously connected to one of our products, which has been manufactured at this and that site, right? Do we have a problem in southern Germany, or do we have a problem in India? Can we analyze it? Can we understand it? Also, if we think about the understanding of this route here, obviously the batch has a lot of materials, like the API or the formulation, where something can go wrong, right? Or that a supplier is not supplying enough, or I don't know, the currency goes up and down in a certain country. How do we have to address that? Should we invest more? Should we buy more and have it in the stock? Should we take? Do we have an alternative? Do we have an alternative supplier for this specific material? Can we synthesize this on our own? These are the kind of questions you can answer very, very quickly using a graph database. Cool. And this is what Mambe is presenting in the afternoon. And I was super impressed by Mambe being a one-man show. Where is he? There's Mambe in the back. You did it in a couple of months as a one-man show. This was super, super interesting to see how quick you moved while harmonizing and cleaning the data. So super excited to have you here. The second one is Jonathan Lowe, who used to work for Pfizer in the US. He's now with his own company, Amalgo LLC, and he has a lot of experience in the manufacturing processes within Pfizer, and you will hear from him. He has a lot of analysis and some models and did some analysis on how to do risk mitigation, how to track and trace the problems. Cool. With this, I'm at the end of my presentation, and just like to summarize again what Neo4j is from the top to the bottom. So we are the database provider that is not only providing you the database, but also the analytics and the machine learning machine learning algorithms here on top of the database. We can query from any sorts of database, and we can ingest that, or we also have a new feature called virtual graphs, where you build a virtual graph on top of your Snowflakes, your Databricks, your SQLs, whatever. And you can query a graph using GQL or Cypher query language. On top of this, we have the consumption layer. There are many different ways how to consume the graph. Some people might want to see graphs. I see Brigitte here, my former colleague in the audience. When I used to be a user, the doctors didn't want to see a graph. They said, like, what are these Easter eggs, Christmas tree decoration? I don't care. I want to have a table. I want to have a signal, a warning, whatever, right? So this is a learning that I took from that sometimes the visualization or the consumption of the graph might be a dashboard, might be a chatbot nowadays. And all sorts of agentic AI, multi-agent connectivity. So we are providing the tooling for that, which makes it a graph intelligence platform. And just to give you that here as a reference architecture, just for the record here, if you're seeing the slides afterwards, I don't want to go into detail with that. So we have reference architectures in any sorts of cloud or on-premise environment here. Reach out to our technical folks. They are happy to help you. That brings me to the last session. As I said before, Jean-Marc is from our Gen AI team. He will demo a little bit the document intelligence. Niels, our product manager for dashboards, will show you some new capabilities of what we call Studio. So stay with us until the afternoon. Just as a summary, 9.8, 9.9, 9.99 of the top 10 pharma companies are our customers. So today it's 9, probably in the next couple of days, the last remaining one will join us here. You see all of different use cases here that I haven't spoke about. One super interesting one is the Open Study Builder initiative in the clinical space using CDISC. You probably heard about the Gilead use case. They are doing drug fraud. So fraud detection with their drugs. AstraZeneca, Novo Nordisk, they have 20 plus use cases. So yeah, we can talk until Christmas about that. In summary, I hope you got a first impression of why we should use knowledge graphs. Graphs are connecting our data. It makes the AI being more reliable, explainable, more accurate, less hallucination. I would doubt that this is like a zero hallucination, but we get there. And yeah, Neo4j gives you everything, not only the database, not only the algorithms, but also the ecosystem, also to our partners, so that you can leverage your data. And with this, I have the last announcement. Just like tonight, we became officially a member of the Pistoia Alliance. You probably heard about Pistoia Alliance, the consortium where a lot of standards are discussed. We're now a member. We are happy to collaborate and bring in our knowledge graph capabilities. And with this, I'm encouraging you to connect today. We have a small audience, so you have a lot of time to connect with the people, ask the customers, ask your competitor, what are you doing? And let's all rock some graphs together. So happy to have you here.